Good morning, guys. This is our project for the day. Little skid steer attachment. Looks like for forks. We got these little slots for forks. What happened here is the little brackets that hold the back side of the quick attach on the skid steer tends to fold these outwards, and that's what's been happening here. Folded it out there and folded it up there, so where they don't hold it well anymore. And so the company sent out a new updated version, which should go in that position right there, and we'll see if it works, right? So my job now is to gouge it off and weld it on. They did some pretty decent welding here. It looks to be a dual shield of sorts, so can't really tell. That looks stick welded, but either way, it needs to come off and be put back on. Ooh, got some welds in here that little sketchy too. Let me see. Yeah, I may fix those up as well. Okay, so the machine we're going to be using today is going to be this HTP invertig 400 AC/DC. Peter over there at HTP sent this over a while back and hadn't been able to use it much because I've been doing a lot of other things. But this is our opportunity to showcase it again. They added a arc gouging feature to this machine, so they want me to test it out and see if it holds up to the rigors of arc gouging. And so far, it's been a great machine. It's been really, really good. So I've been very impressed. 400 amps too. You can't beat that. So stick around. We'll see how to set that up. Well, as I'm going and start gouging. And I'm even going to stick weld it with this thing. I could MIG weld it, but I hadn't stick welded in a while, at least on the channel. So you get to see some of that. All right, let's get started. All right, for some of you who may not be familiar with arc gouging, this is the torch right here. This particular one was used, of course, but this particular one is a Profax model. I like the 3000-1. This is the size right here. The -1 denotes swivel, makes it easier to swivel this around instead of having to swivel that whole cable. And so basically what you do is you add your electrode holder onto the end of this lug that's right here, and you can put another lug with a section of cable, or you can do it different ways, but I like just to bite the end of it with the electrode holder. And then of course this takes an air supply. The air supply comes out at the bottom of these holes right here, so you can see those holes there. And as you put the carbon rod in there, and I'll show you in a second, the carbon will melt the molten puddle of the material, and the air will blow the jet away. Now, one of the things you do have to be careful though with this is sometimes when you get these, you'll have the tendency to want to just put an air chuck right here, but that's not good because this whole brass piece is live at that point, and you'll just come to contact with something, and of course you'll arc and ruin your air chuck. So that's why it's got this little cover here, and it works good. Hard to do with one hand, but I'll show you in a second when I set this camera down. And so basically it's almost anti or reverse stick welding. You just let me set this down for just a sec. All right, so you get this rod right here. It's a carbon rod, 1/4 inch carbon electrode. You can buy those at most welding supplies. I like to grab it about halfway or so. You get comfortable with however long you like to be away from the distance of the material. And as I mentioned, these air jets will blow the molten puddle away. And so one of the keys is to always go in a forward direction. If you start backing up, you will leave a layer of carbon. This will deposit onto the parent metal, and then you won't be able to get underneath it anymore. It'll just create more headaches for you. You have to physically remove it with either a die grinder or maybe the needle scaler will be able to get some of that off. But if you lay a layer of carbon on there, those that know, it is a struggle. So one direction. You always want these air jets to be on the bottom side, towards the side of the parent metal, or towards the side of the initial weld. So as you gouge, the air from underneath will scoop out the molten puddle and blow it away. So that's about it in a nutshell. And for these carbons, I like to use I'd like that to be about 100 and actually about 200 amps for a stick welding machine engine drive. And then for some reason it seems to always come out a little bit lower with a plug-in model, so we'll try about 190. Here you go. Oh, and here's what I was saying about this machine. What's cool about this is that here it says electrode DC polarity, so it's like stick welding. The electrode is positive, but this one has a settings button that'll give me the option for carbon arc. So press that, it's on. Carbon arc is denoted there. DC polarity, amperage, like that. And now it's ready to go. So let's start cutting. I'm gonna turn it up just a few amps more. 190 was a little low. We're going with 197 now. Let's see how this one works. There you go, not bad, eh? So with one rod and maybe about 2 inches of this one, ouch, it's still hot. I was able to get those off. Cleaned off those welds there. Hit that with a needle scaler. Cleaned off that old weld there. And same here, just hit it with a flap disc now, a sanding flap disc, and we should be in good shape. Not bad. not bad at all. But so see how effective it is in erasing welds. This is a really good job. Really fast process. Imagine trying to sit here with a cutoff wheel, trying to make a line, a cutoff wheel there, and a cutoff wheel there to slice off a little pie section maybe, and then try to fit your grinder, you know, within this area here, maybe in some tight spots there. You know, some people are really good with cutoff wheels, and good for them. But when I have something like this, or the access to something like this, it makes it so much easier. So let me clean this up here right quick, and then we can see where they dug in with the grinder. Yeah, kind of exactly what I'm talking about. Could be an issue. So as I mentioned, now it's a matter of gluing it back on. So pretty simple little job. Let's keep moving. Okay, now that I got that cleaned up, still looking like there was some undercut there from the original, where am I at? Grinding, which is fine. That'll be covered with welds, so that's not a big deal. But now goes this guy, right in this area. Many years ago, I made a little fixture that says do not throw away. I used to repair more of these style of quicktach or bobtach, or they got all kinds of names. But basically what I did was I made a fixture to hold the spacing between here where the locking pins go and the top edge of what used to be, I believe, 1.25 inch bar that went all the way across some of these. They're different styles, of course, but this serves the same purpose. And so now what I'll do is ensure that this is nice and tight. Let me scoot this over just for visual. All right, so now I'll ensure that that's nice and snug against this edge right here, and then I'll start tacking that in place, and I'll make sure it fits, of course, on this side all the way across. So pretty simple, but this gives you a good idea as to not having it too far away, too far out like that, and then creating a loose situation to where it'll cause more problems in the future. So that worked really well right there for those other ones that I made. And so that's what we're gonna do. Make that snug, tack it all together, and get to welding it. Oh, as if you can't tell, I turned it around so we can use the advantage of the sunlight, because the sun is coming in. All right, let me go ahead and start tacking these things. All right, so I decided to close the door. Too much light coming in, but anyway, so now we can go back to putting this on to stick welding mode, which doesn't hurt it to leave it on that at all. So now it's on the electrode, you can notice over here. So electrode mode. Now we'll turn it down. Let's start off with about 100 and that jumped pretty good. Let's try 118 to do some tacks. And what's interesting is it gives a percentage of the hot start. I didn't realize that was an option, but I'll just leave it where it's at. I'm not quite sure how to use this machine yet. Let's see. What does it say? Oh, that's a selection. Okay, so here we are, 118 amps. Let's do some tacking. All right, here we go. a little cold. I'm gonna crank it up a couple. Okay, I turned it up to 121. That's a little better. All right, so that looks like it'll do it. Got done with those there. Look okay. Same thing over here. Got a little BB I gotta avoid. I'll clean up. Those on there came okay. Yeah, not bad. So, pretty simple little job, like I mentioned. Just little gluing with the stick electrodes. Hadn't stick welded like that in a small fashion like that in a while. And another thing is I stopped using my auto darkening lens. The batteries went out on it, so it was tough getting used to that again. So that was interesting. But anyway, this machine did really well. It ended up being at 119 amps, so that worked out great. But nice little simple project. Hope I was able to explain some of how arc gouging goes and see how easily you can remove these things. I mean, these things just come off so smoothly, so easily with arc gouging, especially when you get it down. So thanks again for watching. Hope you guys learned something, and we'll catch you guys on the next one.